So, what exactly is periodicity? It's the repeating patterns in the properties of elements as their atomic numbers, the number of protons in their nucleus, increase. These patterns help us understand how elements behave and interact with each other. The idea of periodicity goes back to the 19th century when a scientist named Dmitri Mendeleev noticed something amazing. He arranged the known elements by their atomic masses and saw that their properties repeated in a predictable way. For example, elements like lithium, sodium, and potassium, which are all highly reactive, lined up in the same group. Mendeleev even left gaps in his table for elements that hadn't been discovered yet, and he was able to predict their properties with incredible accuracy. Today, we organize elements by their atomic numbers instead of their atomic masses, which makes the patterns even clearer. This is why the periodic table is such a powerful tool in chemistry. It helps us predict how elements will behave, form bonds, and even react in real-world situations. The periodic table is organized by atomic number, the number of protons in an atom. Rows or periods show elements in order of increasing atomic number, while columns or groups organize elements with similar properties. Classification. Metals are shiny and conductive. Nonmetals are varied but often insulators, and metalloids have properties of both. Next is the key trends in the periodic table. Atomic radius is a measure of an atom's size, influenced by the distance between its nucleus and the outermost electrons. Across a period, it decreases due to a stronger nuclear attraction pulling electrons closer. Down a group, the radius increases as new electron shells are added. Why do smaller atoms pack more punch when it comes to ionization energy? Let's find out. Ionization energy is the energy required to remove an electron. Across a period, it increases because smaller atoms hold onto their electrons tightly. Down a group, it decreases because larger atoms have weaker nuclear pull on their outer electrons. Can you guess which element requires the most energy to lose an electron? Drop your answers in the comments. Electronegativity measures an atom's ability to attract electrons in a bond. It increases across a period, reaching its peak with fluorine, the most electronegative element. Moving down a group, it decreases as atomic size increases and the pull on shared electrons weakens. Fluorine is such a strong attractor that it forms compounds even with noble gases, which are typically inert. Metallic character describes an element's ability to lose electrons easily. This trait is strongest in elements to the left and bottom of the table, where atoms have fewer valence electrons and a weaker hold on them. Which group contains the most metallic elements? These trends, atomic radius, ionization energy, electronegativity, and metallic character, reveal the secrets of the periodic table. Understanding these patterns equips you to predict chemical behavior and properties like a true chemist.